In this course, we will learn how to use Prython. It is a new Python and R integrated development environment that allows you to drop your code into panels that you can connect. It can be downloaded from Prython's page and installed in less than 2 minutes. For this course, I will assume that you are familiar with Python, R, and the most famous libraries such as Pandas, scikit-learn, matplotlib, etc. Let's go back for a second to a typical framework for Python, such as a Jupyter notebook. Here we write our code sequentially, and the previous results alter whatever comes after. Here we have a data loading stage where we read the two files, then we have a merging stage where we merge the two files together, then we have a step where we create the features and the targets, and then we have 5 scikit-learn models, one after the other one. The first immediate problem that we have here is that it's not very easy to separate the different parts of this script. The best we can achieve is to insert some markup and add some titles, for example reach submodel, elasticnet, lasso CV, etc. The second problem is that if I want to create a submodel, for example grabbing either one of the 5 models that I have, for example reach, and modifying a hyperparameter, I can do it here, but it won't look very nice. The best I can achieve is to paste the code in there, for example what I have here below reach submodel, and then add a title that says reach submodel. This works, of course, but what happens if I want to create 10 different types of submodels? It will get really messy and really complicated. There is no immediate way to tell that whatever code I have in reach submodel is connected to the reach model that I have on top, other than by the title. The third problem is that if I want to do a change to my modeling data frame, that in my case I defined here on top of my code, I need to rerun everything. So let's assume that, for example, I want to remove the age variable from my modeling data frame. I can do it and then I can rerun everything, but that has an obvious problem. The problem is that now I will lose all the outputs that were printed prior to removing this variable, and it will be extremely hard to compare what happened before I did that change and what happens after I do that change. This is very frequent in machine learning and statistics. Sometimes we want to remove some variables or create new variables and compare the results for our models before and after. Rerunning our code and remembering what was changed prior to making any of these changes gets really messy. Navigating through the plots can obviously be complicated as well. Ideally, when we look at plots, we want to see all of them together. Here we are not in deep trouble because we only have one of them, but imagine we had 5 or 10 of them for each one of these models that we created. It would be really complicated. Analyzing all the data frames and changes to these data frames in our scripts can sometimes be very challenging, especially when we have lots of data frames and lots of transformations, such as grouping, summarization, merging, transposing, pivoting, reading the data frames, etc. This is how the very same project would look like in Prython. As you can see, it is essentially a canvas where we just put our panels and we put code on these panels, these black panels, and then we connect them and run. So to be more specific, on top I have the first panel where I am reading the data. The panel immediately below that is connected to it is transforming that data by merging these two data frames together. After that, I am creating the X and Y data frames, the features and the targets that I will use for modeling. And then I have 5 different panels below that are connected to this one. Each one of these will be doing a different machine learning model in scikit-learn, the same ones I had before. Look also that I have a text next to each panel that indicates what each panel is doing. On the lower left part, I have a list of these markers that I can use to navigate. I can click on either one of these and I will get redirected to the relevant part. Running this is very easy. With just one click, I press run and everything runs. You can see the data frames that were generated in this code next to the panel that generated or modified them. As you can see, I can create submodels here very easily. I can create, for example, a reach submodel as I had before, and I can connect it to the reach panel. This looks really nice and it's really easy to navigate through my project. Also, as you can see, once this runs, it generates not only the outputs associated to each panel, but also the corresponding plots next to the panel that generated them. So if I had 5 different plots for each one of these models, they would appear next to the panel and they would be very easy to look at. I can also add R code within the same project. For example, here I am creating a panel and then I am just simply reading the same CSV that I was reading in the first Python panel. And as you can see, I run it and it also gets displayed next to the panel that generated this data frame. It allows me to add elements to my canvas to organize my panels better. For example, I can add a bracket, as I am doing here. I can add notes. I can add frames, resize them, and group panels together. For example, here I am grouping them under a common name called reach models. I can freeze the results of my panels, do whatever change I want to my script, rerun everything again, and then being able to quickly compare what I get before and after a change was made. I can attach consoles, R or Python consoles, to each panel depending on what each panel is configured to run. So for example, here I am attaching a console to this Python panel, and then I'm, for example, printing the contents of the X object. And what about the change that I did to my data frame in my Jupyter notebook? How can I replicate that here? Here it's very easy. I can add, for example, 2 panels that will have the exact same content as my initial 2 panels. But here I will add to my second panel a minor change. Remember that I was using a pandas.drop to remove one column in the Jupyter example. So in my upper right part I have the 2 panels that replicate the content of the other 2 panels on the left, except for that extra line that drops the column in pandas. I can hide those 2 panels on the left and run whatever is on the 2 panels on the right, as I am doing here. Check how easy it is to keep track of the different experiments that we are doing here.